Thanks, Kate. Welcome, everybody, and thank you for joining the first of this webinar series. The Strategic Innovation Fund is a £450 million fund invested in gas and electricity network innovation over 5 years. We've just launched round 3 of that and are welcoming ideas through our call for ideas currently. The purpose of these webinars are really to help innovators who want to bring ideas to the fund to better understand what the role of the energy networks within the energy system is. We have previously seen some really great ideas put forwards towards networks, but they haven't necessarily been within the remit of the gas or electricity networks to be able to pick them up and take forward. Similarly, we have some really smart innovators who are coming up with ideas who probably just need to develop their understanding of the role of the energy networks before they'll be ready to deliver a full-scale innovation project of the size that the SIF is looking for. So thank you all for joining. Keep in mind that this is an introduction to the energy network, so any of you who may be quite familiar with them already, this might be covering old ground, but I think that could be helpful as well. Thanks to Kate and Laura and team for putting the webinar together, and I'll let them move on with it. Over to you, Laura.
Great, thanks, David. And welcome everyone to the webinar. My name is Laura Glover. I'm a manager at the Carbon Trust. I'm leading much of our work on energy network innovation and flexibility markets. Today, I'll be providing an introduction to the energy networks. And as David said, this is specifically aimed at those who are new to the sector. So this includes all the startups and SMEs that we have joining the call. And we have a fair number from international markets as well. This is part of a series of webinars aimed at getting you up to speed sufficiently to engage with the networks and participate in ideation conversations with them. But there is only so much I can cover in an hour, and we could spend days covering this topic. So there'll be details that I don't come to on this particular call, but we're very happy to follow up with individuals with any specific questions that we don't get time to cover today. So what we are covering today is we've got 3 main agenda points. So firstly, an overview and introduction to the GB energy sector and its transition to net zero. Then we'll move on to the structure of the GB energy network industry, including the roles, responsibilities of both the transmission and distribution network operators for gas and electricity. And lastly, we'll come on to the challenges and opportunities network companies need to overcome to facilitate decarbonisation and the integration of low carbon technologies. So firstly, with an overview of the GB energy sector. So energy is key to much of life in the UK, and we use about 1,400 terawatt hours of energy each year, which is a really big number. This demand is actually fairly evenly split across commercial, industrial, transport and residential usages. And currently the majority of the energy we use is coming from fossil fuel sources. So about 41% of our demand is met by natural gas, which is largely used for heating. We've got about further 35% coming from oil and petroleum. Very crudely, we can say that this is largely meeting our transport needs among some other sources as well. And the remaining energy demand is met by electricity and a very small amount of biofuels. However, this all needs to change. So we have legally binding targets in the UK to achieve net zero by 2050. We're making good progress since 1990, which is our baseline. We've almost halved our energy emissions, our overall emissions in the UK, but we're only halfway through this journey. And the second half is actually going to be more challenging than the first. We've done all of our quick wins, low hanging fruit, but there's still quite a long way to go. And energy is a really big part of this journey, which will be quite a big area to transition as we go forward in the next few decades. What this transition needs to look like? Well, if you look at the chart on the right, this is the Climate Change Committee's best view on what might be needed to continue to meet our energy demand whilst transitioning to net zero. We can see a consistent decrease in gas demand in the top left, as it's phased out largely from use in the buildings and manufacturing sectors, and a similar trend in the oil usage underneath it, where you can see a phase out from oil usage in surface transport, so all of the cars, trucks on the roads, buildings, shipping and manufacturing. But we will see some ongoing usage from aviation if we're following this pathway. However, we still need to meet all of that demand for using energy in our everyday lives. So we see electricity on the top right, which will be largely filling some of that gap in the building sector in particular, but also taking on some of the demands in manufacturing as well. On the bottom right, we have hydrogen, which is a very new source of energy being used globally, but in the UK in particular. And we're kind of expecting our use of hydrogen to go up in the next couple of decades. So this will help meet our demand for electricity supply, but also in shipping and manufacturing, especially in the heavy industry sectors. There'll be potentially some role, but a fairly low role in building and surface transport as well. These trends both mean that electricity and gas networks have a core role to play in achieving these net zero targets, with a lot of evolution in the way these networks running being absolutely key to achieving net zero. On the electricity sector side of things, we have two problems. So the first being that electricity demand is going to be going up significantly as we transition away from gas and oil usage. As we mentioned, a lot of this coming from building usage, both residential and non-residential, manufacturing, a bit on fuel supply, a bit on meeting our hydrogen need as well. And on the right-hand side, you can see that alongside meeting this increase in demand, we also need to change our generation mix. So all of the technologies that are actually producing electricity and feeding it into the system. So we are moving away from the unabated fossil fuel generation in the purple on the very bottom, and largely replacing this with variable renewables instead in that kind of mauve shade that makes up most of the chart. To match this variable renewable supply, we also need to have some firmer sources of power. So there will be an ongoing role for nuclear and potentially some dispatchable generation fueled by hydrogen or maybe CCUS as well. So carbon capture, usage and storage technologies. So that's a brief overview of where we are and where we need to get to from an energy-wide perspective. Moving specifically into gas and electricity networks, which are the main focus of today's webinar. These are going to be crucial to the transition to net zero. And in the next section, we'll go through the structure of the system and the roles and responsibilities of the stakeholders in it. We'll be starting with a more historic view of the system from when it was largely fossil fuel based, largely because this is the structure that has defined many of the roles in the system that we see today. And secondly, just because it's a little bit simpler to get your head around. So we'll start from there and build up as the system is going through this change. In the last section, we'll come on to how these roles and responsibilities are changing as the networks need to decarbonise. So firstly, with the electricity system, we can largely split the technical, physical parts of the electricity system into four main stages. So firstly, energy generation, which is the process of turning primary energy sources into electricity. Largely, this has historically been from burning fuels, which then generate steam to turn large turbines and change this kinetic energy into electrical energy. This is then transmitted around the country via our extra high voltage transmission network, which is the big metal pylons that you'll be familiar with seeing around the country. This extra high voltage is required to reduce losses over these very long distances that we need to transport electricity over. Some large demand users will be connected directly into this transmission network, such as heavy industry. But in most cases, the extra high voltage power is then stepped down to a lower voltage in the distribution network. This is a smaller series of pylons, overhead underground lines, substations, which the smaller energy users, including retail, light industry, residential usages, are connected to. There are a lot of different players who play a big role in making this system work. So in the UK, we have what's called an unbundled market. So we have different stakeholders involved in each stage of the process. So generation is a competitive space with multiple different companies owning, operating the generation assets, from the big gas power stations to the offshore, onshore wind, to the solar farms that you'll see around the country. And they're all competing to sell their output to make a profit. Some of these names you'll probably recognise, such as E.ON, Drax, Scottish Power, amongst many others. They sell their power to the other part of the competitive part of our market. So these are the energy suppliers. These are companies with the responsibility of selling that power onto end consumers. And again, some familiar names here, probably for most of you: Octopus Energy, EDF, OVO, Scottish Power, again, amongst many others. Transmission and distribution networks are slightly different. So these are regulated companies. They're still privately owned, but they're regulated by our energy sector regulator, Ofgem, and there's limits on the amount of profit that they can make and the charges that they can pass on to customers or need to be approved. We have the transmission network, which in this case is owned by National Grid in England and Wales, and Scottish Power and SSE Networks own the transmission cables in Scotland. On the distribution side of things, we've got 6 distribution network operators. So we've got National Grid electricity distribution down in the southwest and the Midlands. We've got UK Power Networks in the southeast. We've got Scottish and Southern Energy, SSE Networks, who are in the south and in the north of Scotland. We've got Scottish Power Energy Networks, which covers the central belt of Scotland and the Manchester and North Wales area. We've got Electricity Northwest and Northern Power Grid, who have the northwest and the northeast areas respectively. Our last regulated business in the sector is the system operator, which we haven't actually covered at all so far. This is National Grid ESO, and they're responsible for monitoring and controlling the system to ensure system stability. At the bottom, we've got Ofgem, who's the regulator for the energy sector, and they've got the remit for protecting customer interests and ensuring the stakeholders in the system are playing by the rules. And lastly, we have the Department for Energy Security and Net Zero, who have the responsibility for setting energy policy in the energy sector. So this includes the net zero targets we mentioned earlier and how those come into force. We've got the energy market reforms, we've got support schemes for renewables will all be under their remit. So a little bit more on the responsibilities of these different network organisations in the electricity space, starting with transmission network operators, and you'll often hear the acronym TNOs kind of getting chucked around quite a lot. So they've got the responsibility for owning, maintaining and operating the high voltage network. They've also got the responsibility for investing in building out new infrastructure as it's required as the demands change on the system and new generation needs to connect. They've got responsibility for facilitating these new connections and providing visibility on where there is space in their network for connections, and the same with large demand onto the network. They're also responsible for resolving any outages that happen and managing voltage levels across their network. In terms of ownership and cost recovery, it said they're privately owned, regulated by Ofgem, and they can recover costs through 2 main mechanisms. There are some others, but principally it's around connection costs as different users connect to the network, and transmission network use of system charges, casually known as TNUOS, which is another acronym you'll hear chucked around quite a lot, which are costs recovered from all of the different users on the network. Similarly, we have distribution network operators, DNOs, lots and lots of acronyms that we'll come on to. Similar sorts of responsibilities here. They own and maintain the distribution network, so those lower voltage levels that take power into people's homes off the transmission network. They're responsible for connecting the smaller generators to the system and demand onto the network as well. They have responsibility for planning, delivering investments in the network, and operating and administering the MPAN system, so the meter point administration system, and allocating supplies to each of these supply points. And like the transmission network, they're responsible for resolving outages on their network as well, which could happen for a number of different reasons. Very similar in terms of ownership and cost recovery, privately owned, regulated by Ofgem, and they can recover their costs largely through connection costs and distribution use of system charges. Not TNUOS, unlike the transmission network use of system charges, just DUOS in this case. And lastly, on to the system operator. So they've got a remit for monitoring and controlling the balance of supply and demand and network system operation. And this is happening 24 hours a day, 365 days a year, second by second. With electricity system operation, we have to make sure that supply and demand is balanced at all times in order to keep our frequency of the system within the limits that have been set. And this is to avoid outages, blackouts onto the system. This means there's very close control that is needed, and especially as the system becomes more complicated, this becomes a bigger task for the system operator. They've got a number of tools at their disposal. They can ask generators to turn up, to turn down. This can happen through a number of different ways. This can be through a process called the balancing mechanism, which is a close to real-time market where they can pay or get paid to turn generators up or down, and the same with some of the demand as well. But they can also procure these services a long way in advance as well. And these are called ancillary services. You'll often hear the term balancing services as well. On to the gas networks. So with the gas value chain, it's a very similar sort of process to the electricity system. We've got production on the left-hand side, where we've got the different sources of gas that are coming into our networks. So this could be from LNG terminals. We've also got direct input from our offshore drilling in the North Sea and a bit in Irish Sea. We've got some interconnected pipe work with the rest of Europe as well. And on a smaller scale, we've got some biomethane generators who inject directly into the system as well. They inject generally into the transmission system, which is our higher pressure network, which is effectively the motorways of the gas network, covering the whole length of the country. This runs at quite a high pressure, anywhere between 16 bar and 100 bar at different points in the network. And there are various different compressors along these networks as well to help maintain that pressure at the flow we need it to ensure a good flow around the network. Also connecting into the transmission network, we have storage vessels, and these play a key role as buffers to peaks in demand and help with managing flow in and out of the network so that pressure is maintained. Some customers, again, are supplied directly through the transmission network. So this includes the electricity sector, where we often burn gas as part of our gas power stations, and also the industrial sector as well, especially the kind of heavy industry sector. However, in a lot of cases, this gas flows directly from the transmission system down into the distribution system, which again is a kind of a lower pressure system. It runs generally between 2 to 7 bar in kind of the higher parts of this system, right down to about 75 millibars going into residential and commercial properties. Similar to the transmission system, there are either pressure reduction stations or gas governors, but they play a similar sort of role of maintaining flow through the network. And then we've got meter points at each of the different points where we're supplying actual customers and end users of the network. Okay. In terms of who these stakeholders are, again, is a very fragmented landscape compared to some other parts of the world due to the unbundled system that we have here. On the left-hand side, we've got producers and shippers. So these are the ones who are so the producers are bringing the gas to the connection points into the system, and they sell this on to the licensed shippers, who then own the gas as it travels through the network of transmission and distribution pipes and arrange for it to be conveyed to the supply points in the network where their demand is. They sell this gas to the other part of, I said, the unbundled competitive part of the network, which is the gas suppliers, who will be responsible for selling it on to the end customers. In the middle, we have the transmission and distribution networks. As with the electricity system, these are regulated monopolies, similar to those. These are regulated monopolies. So this is National Grid Gas Transmission for the transmission network, and they own and operate the transmission network with similar sorts of responsibilities to National Grid on the electricity system and Scottish Power and SSEN. Responsible for investing, responsible for maintaining, responsible for owning all of these different pieces of infrastructure. For distribution, we've only got 4 gas distribution network operators, or GDNs, unlike the 6 that we've got for the distribution network operators. So we've got Cadent Gas that covers most of England and the Midlands. We've got SGN, which covers all of Scotland and the south of England. We've got Wales and West Utilities, who have Wales and the southwest, and we've got Northern Gas Networks, who covers the north of the country. Again, these are kind of regulated industries. There's a limit to how much profit they can make, and they've got Ofgem who are overseeing this. Also, like with the electricity sector, most of the policy steer is coming from the Department of Energy Security and Net Zero. Okay. So that hopefully provides a bit of an overview of where all of the different roles and responsibilities in the energy sector sit. But this is largely what has been, and to an extent what is. In order to meet net zero, we need a lot of different change in the way the system is operated, managed, and the technologies that are assisting us to do that. So going forwards, the scale of transition needed to reach net zero is absolutely immense. We need to probably triple the current electricity capacity connected to the system, depending on exactly which pathway we take, but that's sort of a magnitude. We need to unlock 40 to 110 billion of investment in electricity network infrastructure. We're looking at a doubling of peak demand on the system, alongside facilitating new technologies such as demand side flexibility, so having our demand responsive to the needs of the system. We're transitioning 100 terawatt hours of electricity for use in transport, and we currently have about 2 connected to the network. So again, a massive increase that's needed. And we're looking to enable about 80 gigawatts of hydrogen production capacity over the coming couple of decades. So really, really big change that's going to be needed. This also means that our system is going to get much more complicated. We've got a lot more variable renewables that are connecting to the system, and they'll be meeting a large amount of our energy needs. So that's onshore wind, that's offshore wind, that's solar PV, all of which, well, we can't control when the wind blows or when the sun shines. So in order to manage this, we also need a lot more flexibility assets coming into the system. So these are sources of energy demand or energy generation that we can turn up or down as needed to match the variable output of our generators. There are a large range of options here, and we're probably going to need all of them to operate the system at the lowest cost possible. So this includes battery storage, and already we're seeing a lot of batteries connecting into the network, and they're playing a vital role in managing that kind of hour to hour, second by second matching of supply and demand in our network already, and we need far more of them to come. We're also going to be seeing a big role for thermal energy storage, demand side response, greater interconnection with our European neighbours, and also more generation that is dispatchable but coming from low carbon sources. So this might include hydrogen generators, and it might include our existing gas generators, but with carbon capture and storage to reduce the emissions that they might cause. So lots and lots of change that's needed. On the demand side, we've got heat pumps coming in, we've got electric vehicles coming in. We're probably going to have a greater uptake of things like heat networks, which are all new things for the network operators to manage. And we're still not entirely sure exactly what these load profiles are going to be, so how customers are going to use them and how much flexibility we'll have in changing that usage. So lots of uncertainty here, as well as lots of complexity. Another thing that's changing is the geographical spread that we're seeing within the locations of these generators connecting to the system. Historically, you can see on the left-hand side, we had a few big generators largely located close to our sources of demand. So you can see we've got a big hotspot in the Midlands where we have a lot of our heavy industry located, and you can see close to where we've got a number of big cities, we've got a lot of gas capacity as well. As we move to renewable-based system on the right-hand side, you can see that this is a completely different pattern, and it's entirely dominated about where resource is. Where is there high wind speeds? Where is there lots of water? Where is there lots of sunshine? This is not correlated with where demand is, and this is going to place additional burden on our electricity networks in particular to make sure that we can get this generation from the source where it's generated down to the demand where it's going to be used. So all of this together, the geographical, the temporal issues with system operation is leading to a lot of challenges for the networks. I've just flagged a few here now, but these are just a few that we're seeing being discussed a lot by our network operators. So first is managing supply and demand. Generation will largely be from variable renewables, and this means that we'll see large seasonal and daily variations in its output, and this is going to be challenging for the system operators to manage. We're also going to be seeing high levels of volatility in demand, especially from heat. So at the moment, our gas boiler fleet in everyone's homes can ramp up and down very, very quickly. Seeing this additional load come on the electricity network is going to cause massive spikes in our demand, which we're going to need to be managing. Secondly, we've got network constraints. So these can be thought of as bottlenecks effectively on the system, where we just have either too much power coming into the system or too much power coming out of the system, which basically overloads some of those cables. Due to the different geographical spreads of renewable generators and also increasing demand, especially in our cities, we're seeing more of these bottlenecks happen. And this is a big challenge for the network operators who are responsible for just making sure that the power gets from where it's generated to where it's used. And so resolving these issues is very top up their to-do list. This is also reducing the ability to connect new generators to the network, which, as we said, we need to triple the amount of generation we've got connected to the network. So these constraints can really hinder that deployment of renewables. Thirdly, we need far more cross-vector coordination. As we saw in the previous slides, we've got a lot of need from the gas and potentially hydrogen as well to help manage the supply and demand in the electricity system. So we need to be talking far more rather than operating these two systems independently as they meet two independent energy needs. Fourthly, we've got system stability. So previously, we had these really big power plants, which you could turn up, turn down whenever you wanted. And they also had the benefit of really increasing the stability of the system. They were a big buffer. All these big turbines are a big buffer. That means the frequency in the system could just be buffered a bit so it doesn't change as rapidly. And that makes it easier for the system operator to manage. So we're seeing reduced system inertia, which is that kind of buffering effect. And we're also seeing bigger changes in voltage and reactive power issues at all voltage levels as different renewables connect into the system. And they've got different characteristics around how much reactive power and voltage they're putting into the system. And lastly, we need new black starts. So black starts is what we would do if the whole network shut down, which hopefully will never happen, but is definitely a contingency that we need to think about in terms of network operation. Previously, we had these big power stations. You could put more coal and gas in and use them to help restart the network. If we take those off, we're going to have to look at alternatives in terms of how we can do this black start capability. Next, we come on to data and digitalization. As everything becomes far more complex, as all of the variabilities in the system become far greater, especially close to real time, we need to sort out data and digitalization. More decentralized energy supply flexibility requires higher levels of two-way data flows between the stakeholders. It's not as easy as the system operator calling the big generator and go, can you turn up tomorrow? We suddenly need to coordinate hundreds of different generators and enable our demand side to also participate in network operation as well, if we're going to do it at a low cost. And this leads on to cybersecurity concerns as well. Our electricity infrastructure, our gas infrastructure is a key security issue for the UK. And if we don't get cybersecurity right, then that's a big risk for us. It would be a very vulnerable area if we knocked out our electricity system. Forecasting and planning is the last area. There's still a lot of uncertainty on the pace of change and the extent and rate of deployment of certain technologies. This makes it quite hard for the network operators to plan exactly what's going to come onto the system when, and when they need to develop new capabilities to manage those systems. So as we get closer to deployment of more of these assets, obviously that will become more certain. But right now there is a big gap in terms of exactly what the 2050 energy system might look like. There are lots of different pathways we could take to get there. Okay, but we are looking at different roles, responsibilities to tackle some of these challenges. The two that you'll come across most frequently are DNOs, which are transitioning to become distribution system operators, or DSOs, if we are going to use the acronyms. So DSOs are expected to be an extrapolation of the existing DNO role, but they're meant to be playing a far more active role in forecasting and managing energy flows on the network. To date, the distribution network has been far more of a passive pass-through from the transmission network to demand. It's largely been one direction of energy flowing through. But as we get more generators connecting directly onto the distribution network, we're seeing two-way flows of energy. And we're seeing far more variability in things like network constraints, different times of day. This can really, really vary. And again, the kind of issues that we see around voltage and reactive power as well. We also expect DSOs to play a greater role in procuring flexibility services, especially as an alternative to network reinforcement. Reinforcement being when we're paying to upgrade all of our different cables, either put bigger ones in place or replace old and outdated ones as they approach their risk of failure. So instead of investing in these high cost new pieces of infrastructure, we can use flexibility to manage those different constraints of the network. So either asking generators to turn up or turn down, or the demand side to do the opposite to reduce that demand to the network. We're giving, through DSOs, we're giving the DNOs the kind of responsibility of doing this and be an active kind of participant in managing their network. On the other side of things, we've got the ESO transitioning to become the FSO, so the future system operator. The FSO is anticipated to be publicly owned with operational independence from government. They'll have a remit across the electricity and gas systems, more broadly across other vectors if needed. And hopefully this will tackle some of those coordination issues, especially around the kind of forecasting and planning side of things as well. They've got a remit for conducting whole system energy planning, and they'll be responsible for energy resilience as we go forward as well. So these are just a couple of the new roles that we're making to help facilitate some of the energy transition. Alongside this, there's lots of other different bits of work going on to tackle all of these different challenges. We've got lots around technology innovation and seeing, for example, all of those new batteries connected to the network. We're seeing investment in hydrogen and what that needs to look like to help facilitate meeting our energy demand. We're seeing updates in markets, so the balancing markets, the flexibility markets that we covered as part of the DSOs, and this will help the system operators in managing all of that variability coming onto the system. And we're also investing in better metering and control systems, so giving greater visibility of where and when different peaks in demand are happening across the network. However, there is still a really big role for innovation. And with that, I'll pass back to Kate from Innovate to cover a bit more on how the SIF can help with that.
Thanks, Laura. Wow. That was a lot of information. So thank you for that. It's just to remind everybody as well, if you've got any questions for Laura, we do have time for Q&A at the end. So please do add those to the Q&A box. If you go to the next slide, Laura. Great. So like Laura said, she's kind of gone over some of the ambitions that we have and that there'll be massive change for the energy networks and some of the general challenges that the energy networks will face. Now, David did explain at the start that the reason we're running these sessions is to help educate innovators about the energy network sector to get new ideas in that will help the networks think and do things differently to achieve some of these challenges and ambitions. So this is exactly what we're doing through the Strategic Innovation Fund, or SIF for short. It's a partnership with Ofgem and Innovate UK, and we have £450 million over 5 years to look at energy network innovation. We are now on round 3, and we've already awarded almost £19 million, and we're just about to announce, I think, another 80 million in the next few weeks. We run the SIF as an annual challenge, and we have 3 phases within it. So we have what we call a discovery, which is a feasibility, an alpha, which is prototype and testing stage, and then a beta, which is the full-on demonstration phase. Now, any projects or proposals that come through this must be led by an energy network, but they have to team up with a variety of partners. And any of the ideas that we have obviously have to be within the remit of the energy network. And after today's session, hopefully that's a lot clearer. But any ideas and projects which come through have to create benefits for energy network users. If we go to the next slide, please. Now, the reason I'm telling you all this is that this is not just a one-off, this is an annual process that we follow. We use this phrase giant leap together, and it's a 4-stage operating model, which starts with challenge setting. So earlier in this year, we did a ton of stakeholder engagement, and this really helped us draw out some of those barriers and enablers to energy network innovation, or meeting some of those ambitions that Laura covered. So what we do is we publish a challenge document every year, which we seek ideas and out-of-the-box innovations to address. So that's already out there. We'll share a link in just a moment with those in. Then the next phase is ideation. So this is the bit that we're in now, and the reason I'm telling you all this. So we run a whole heap of events for innovators just like you to get insights into these challenges, get more information on the energy networks and the regulation and more. And in a moment, I'll share some events and how you can get involved. The next stage is incubation. And this is all about how can we take ideas that come through to address some of our challenges and build the best partnerships to really help deliver the best projects. And then our last stage that we have is what we call acceleration. So for successful ideas that have secured funding, we will work with innovators and networks very, very closely to develop their projects as they move through those phases, so that discovery, alpha and beta phase. And we do this to really make sure that we can embed the innovation into business as usual as quickly as possible, so we can get benefits back to the energy bill payers and consumers. If we go on to the next slide, please. So as I mentioned, we have 4 challenges out already at the moment. So challenge 1 is our whole systems challenge. So it's about strategically improving and evolving the planning and connection processes to help meet net zero in a timely and cost-effective manner. Challenge 2 is about developing and scaling technologies and processes and markets which will deliver a fair net zero electrical system. If you don't know what markets means yet, we have you covered in one of our sessions, so I'll share a little bit more in just a moment. The third challenge is all around electric heat. So how can we better coordinate and get visibility of electric heat demand so that we can plan things like flexibility better? And then the 4th challenge that we have is about unlocking system benefits and long duration storage potential for things like power to gas technologies. These are the challenges that we are looking for ideas right now. So if we go on to the next slide. Like I said at the start, we'll be sharing this with you, but you can Google this now by just Googling Ofgem SIF. That challenge document is available. You can find out a lot more about the individual challenges that I just mentioned. We are looking for ideas, and you can submit ideas already for those challenges through our call for ideas process. So this is a chance to get your idea in front of the energy networks. It's a super light touch form. It's only a handful of questions which would talk about the problem statement your innovation's trying to address, what that might look like, and some of your partner aspirations. Then what we do is, for suitable ideas, we offer a pitching slot in front of the energy networks. And what we'll do is when we, if an energy network takes an idea forward, we work with those parties to really develop the best partnerships and connect you to the right people. I just really want to stress the point here, the call for ideas is super lean. It's just a couple of questions. You don't have to have a fully formed project yet. It's okay if you're still starting out, but you've got a good point to start to in addressing one of those 4 challenges. But I just want to highlight 2 dates to you. So we run this process in 3 tranches. The first tranche is already closed. The second tranche closes on the 26th of July. And then the very last one is the 21st of August. So that's just for this year. Like we say, we run this on an annual cycle. Now, the other thing that I want to make sure you're aware of is we do a ton of sessions to support innovators. And really the best way to find out about this is via our newsletter. So it's worth signing up to that. If I go on to the next slide, please. So this is the last slide for me. I just want to tell you about a couple more sessions that we're hosting with the Carbon Trust. So we've got 3 more in our educational series. We are also running a couple of thematic workshops. So for the educational series, this is a follow-on that we'll be hosting around policy and regulation. So a bit more about what that regulatory environment looks like. We're hosting a 3rd one around market access and commercialization. And then the very last one's about innovation support. So this will cover things like funding and skills and that sort of thing. They are really focused for, they're really there for innovators. So please do come along and ask questions. Lastly, we are, like I say, running some sessions that are around certain themes. So we have multi-vector energy systems as one of our ideation workshops. We have cybersecurity, long duration storage, and the last one, which is market and regulatory and innovation. So these are an online workshop where we get breakout rooms, guest speakers to really draw out some ideas and work with innovators and the networks to develop the project. If that's a topic of your, if one of those is a topic you're interested in, I would really encourage you to sign up. What we saw from last year is around, I think it was more than 50% of the successful applications all came through this process. So there's huge, huge value in you attending. For now, I'm going to hand back to Laura for any questions that we've got, and I'd invite my colleagues David and Manu back on the call to help with that.
Cool, thanks, Kate. So we have actually had a few questions come in. We'll just start with a couple which I think are more aimed at your part of the presentation. So firstly, for each challenge, what technology readiness level are you seeking to support?
Happy to take it if you want, Kate. So
Yeah,
we work across the technology readiness levels a little bit more than other innovation funding programs. So because of the discovery alpha beta process, you may have something which is a relatively low TRL, which can be scoped out in the early stages. It's something that needs to be able to be accelerated quickly enough to deliver a large-scale demonstration project in around a year's time. But the discovery phase really tends to focus on the problem rather than the solution at first. So it might be quite a mature technology, which is just ready to be integrated into the networks. And we sometimes use the term integration readiness levels in that instance. But it could also be something which is quite early stage, but is likely to move quite quickly and be able to contribute in quite a short period of time. So we don't have hard and fast rules around that. Tend to range from the sort of TRL 3 to TRL 8 sort of level.
Well, thanks, David. And then just a related question on that, and we can come to Paul. I think I saw your hand go up. Could you possibly put your question in the chat for me? That'd be great. But a related question is there a technology roadmap that links all the challenges and shows when the key deliverables for net zero need to be met?
Annie, do you want to have a crack with the challenge documentation?
Yeah, can you hear me okay?
Mm-hmm.
Yeah.
So what I think Kate and David have mentioned is, so what we do is every year we publish a challenge document that sets out what we think are the kind of most pressing energy system, energy network challenges, and we invite applications against that. But it's a good question, which is, do all of these different challenges come together in a roadmap? I think it's no. I think the reason is, I think there is some ambiguity and uncertainty in exactly what we want the energy system to look like. So it's not that we are all working towards a blueprint that we know what the energy system needs to look like in 15 years and working towards that. In some instances, that's true, but in some instances, a lot of this innovation is really about creating the innovation evidence for us to figure out which trajectory to take and what energy system configuration to pursue, and also what not to pursue sometimes. So we do take quite a broad view of what innovation is, and sometimes it's just about telling us which way we need to proceed and how we need to configure our system. So unfortunately, we don't have a predefined kind of blueprint that we're working towards, but we do have kind of broad areas of interest, which will continue, through our challenges. So for example, energy networks role in decarbonizing kind of heat and transport is not something that we can solve in a couple of years. We're working towards the 2035 policy goal of a net zero power system, and that's got a kind of range of issues, like how do we accelerate the connection process all the way through to improving resilience, cybersecurity, how do we manage kind of stability of that system. So those are some kind of systematic issues that we will work through. Hopefully that kind of gives you a view. I think so between the broader energy system challenges, policy direction, and our innovation challenge document we publish every year that kind of broadly sets the strategy of kind of what we're interested in.
Great, thanks, Manu. Oh, David, something to add?
Yeah, and just to flag a couple of areas through the round 3 challenge setting process that we acknowledge need more work, but are priority areas for us next year are transportation, particularly heavy duty transportation. So we'll be working to try and align the strategies between the transport sector and energy sector to understand what the needs of those are. So if you're looking 12 months ahead, that's likely to be a focus area for next year, as well as supply chain considerations, which include how do we select energy pathways which are going to be resilient from a supply chain perspective, and some of the other outstanding questions around how do we ensure net zero to be able to roll out the assets at the scale that Laura mentioned earlier on. So those are 2 areas, if you're looking for the next round, that are likely to be a focus area.
Great, thanks, David. Okay, onto a slightly more technical question now around the network reinforcement decision-making processes. I'm going to give a very kind of high-level answer now, but happy to pick this up in a bit more detail offline if that's useful. So at a very high level, each of the network companies will do an assessment for the next 5 years, a 5-year development plan of what the new loads they're expecting to see on the system are, map that against the historical loads that they've got metered data for at different points of the network, and assess whether each piece of network infrastructure is going to be reliable going forwards for those additional loads, or whether it needs upgrading or replacing. Generally, at this point in time, the networks will replace that piece of infrastructure, whichever the kind of weakest point is on that network, with the next size up that will meet that demand that is forecast within the next 5 years. Additionally, alongside that process, for the last few years, they've also needed to look at flexibility as an alternative to that network reinforcement. So for this, it's a sort of similar process of that initial assessment of where do they think the challenges are for each piece of network infrastructure, and instead look at, well, what is the opportunity for flexibility to reduce the load or manage the generation on that particular part of the network, so that the piece of network infrastructure doesn't go above this threshold. This is done through a specific tool called the common evaluation methodology, which is common across all of the distribution network operators. And there's a slightly different process at transmission network, but it's basically a cost benefit of, is it cheaper for them to get flexibility, or is it cheaper for them to reinforce? It's like a really quick answer with lots more levels of detail underneath it, but hopefully gives a flavor for how that decision is made. The next one is there a framework for virtual power plants implementation, which is a really interesting question. And a short answer, no. We group virtual power plants, which are a form of unlocking demand side flexibility or aggregating very small generators to enable them to participate in things like the ESO balancing services. We group that as a form of flexibility. They participate in a lot of the different markets that are available to enable flexibility. So that's across the ESO, it's across the DSO. We also see virtual power plants participating as part of the capacity market as well. So it is quite a disparate landscape of where they are active. Across all of those different areas, there are different roadmaps on how we can encourage greater amounts of flexibility to participate, but I don't think there is a single framework for how these are implemented. But we are already seeing quite a lot of virtual power plants action within the UK. Manu, David, anything to add on those?
Yeah, just something maybe to join in some of the markets discussion to understand how virtual power plants and flexibility providers aggregate to participate in those markets.
Yeah, really good point. Okay, that's actually all of the questions that I've got in my chat. If there are any more from the audience, get them in within the next few seconds. And if, oh, I've got one more coming in. Oh, with the expansion of transmission networks, is there any plan to make sure maximum utilization of assets? Because variability of renewables would be a big challenge. I agree entirely, it's going to be a really big challenge. And yes, I think is the short answer to that there are lots of different innovation programs that are ongoing on how we can maximize the use of the existing transmission network, alongside almost an inevitable need that we are going to need to build new transmission infrastructure as well. So there are different programs here, for example, looking at things like superconductors as part of recabling our existing pylons. So I think yes is the short answer, but lots more work to do. Anyone from the Innovate team, do you have specific examples that you'd like to share here?
I mean, yeah, I think it's a good question. It's a big question.
It's a big question.
Yeah, I mean, from SIF, we are already supporting a few projects that's kind of looking at this. So we've looked at projects, for example, that are doing like meshed DC networks that could allow kind of faster connection, better utilization of offshore wind farms from a kind of resilience perspective as well. So rather than doing a lot of kind of single point connections, doing kind of multi-point connections to a single kind of hub, and then having things like circuit breakers that allows you to isolate it. So I think there's a lot of kind of resilience consideration along with utilization. We're also looking at projects potentially looking at curtailment reduction as well. As Laura was saying, yes, we need to build kind of more transmission networks, and I don't think we can get away from that. But also things like how can we use better flexibility or even kind of cross vector, can you convert it to kind of hydrogen potentially for kind of improving the utilization of wind farms, which otherwise might be curtailed, to allow decarbonization of other sectors. So I think those kinds of kind of whole system approaches to improve utilization is also something that the SIF is interested in.
Just to flag that is a thematic area under challenge 1, I think, in round 3. Manu, is it? We're looking at novel ways to try and improve the usage of intermittent renewables and reduce curtailment. One of the important points in this is currently there are curtailment payments made to generators. So effectively people are paid to switch off generation. And part of the challenge within that is how do we bring alternative mechanisms to utilize that renewable generation to low enough cost that it actually becomes economically more efficient to utilize rather than take a curtailment payment. So that's an important sort of target to hit if you are looking at a solution to address that.
Thanks, David. So one more example of something that's slightly different on that is there are a few different projects that are looking at dynamic line ratings as well. So seeing if we can change what those maximum ratings are of different pieces of infrastructure based on the temperature outside, which influences the capacity of the line, and therefore make better usage of our networks at different times of day and different seasons. Moving on to another question that's come in. Would improving the electrical efficiency of equipment such as EV chargers fall within the scope of SIF, given the estimated growth in energy demand for transport?
I could take that one. The electrical charge points would not be within the scope of the SIF. So that's not something that the energy networks can own and operate. But what may be involved in the SIF is if, say, the use of smart charging coupled with other sources of flexibility could support the energy network. So in its own, no, but perhaps with other sources of flexibility potentially.
Okay, thanks, Kate. And probably a great question to finish on is, when will we share the recording? Will you share the slides too, please, so that any links can be followed? Absolutely, we will share the slides alongside the recording of this webinar, which will hopefully go out later on this week. So watch this space. Great, and that is currently all the questions on my Q&A list. So thanks very much, everyone, for attending this webinar, and tune in to this Thursday's webinar on policy and markets, which will be happening at the same time. Thanks for listening, everyone.